Okay, today we are going to be talking about probability, and we're going to be talking about combinations of things that happen in probability. And I think actually instead of calling this combinations, I'm going to call it counting outcomes. I'm going to change that just a little bit. Okay, so one of the words that we're going to be looking at to describe all the outcomes in a particular event is called a sample space. I'm going to make that bold and red. Okay, sample space is a list of all the possible outcomes. So if I ask you what's the sample space when you roll a number cube, I think you could probably all tell me, oops, that the things that can happen would be you can roll a 1, you can roll a 2, you can roll a 3, a 4, a 5, or a 6. So this is the list of outcomes. And if I ask you for the number of outcomes, you would tell me that there are 6. So this is the list, and that's the actual number. So if I ask you what's the sample space when you flip a coin, well, you can say, well, the sample space is what could happen. It could land on heads, or it could land on tails. Oops. Okay, so this is the sample space. But if I just ask you how many outcomes, you would just tell me that there are 2. So this right here is the actual things that can happen, and this is just the number of things that can happen. Now, what's the sample space when you flip 2 coins? Okay, so if I do one flip, so I'm going to say flip number 1, I can get heads or I can get tails. There are 2 things that can happen. If I want to do a second flip, then the second flip could also be heads or tails, but that would mean that the combination could be that I flip heads and then heads, or I flip heads and then tails. I flip tails and then heads, or I flip tails and then tails. So my sample space is heads, 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 tails, tails, heads, tails, tails. And then if I ask you how many outcomes, when you look at the combination of these, there are 4 possible things that can happen. Okay, so that's the sample space and the number of outcomes. What is the sample space when you roll a number cube and flip a coin? Let's see, rolling a number cube. So the first thing would be the number cube. I could get a 1, a 2, a 3, a 4, a 5, and a 6. And then I'm going to do a tree here to say, gosh, from each of these, I could either get heads or tails, right? So there's 2 things that can happen in the second thing. So I could get heads or tails. I could get heads or tails. I could roll a 3 and get heads or tails. I could roll a 4 and get heads or tails. I could roll a 5 and get heads or tails. I could roll a 6 and get heads or tails. So my sample space is a list of all the things that can happen. I can go 1 in heads, 1 in tails, 2 in heads, 2 in tails, 3 in heads, 3 in tails, 4 in heads, 4 in tails, 5 heads, 5 tails, 6 heads, 6 tails. This is the sample space. If I ask you the number of outcomes, how many things can actually happen, we're going to say that there are 12 outcomes. So the number of outcomes in the sample space are actually different. Sample space is where I'm asking you what all the different things are that can happen when you put these 2 events together. And the number of outcomes is just saying how many things that can happen. Now, number of outcomes is kind of cool. You can kind of figure it out easily without making the whole sample space. You just do the number of outcomes in the first event times the number of outcomes in the second event. So in this one, we would say, well, when I flip a coin, 2 things can happen. When I roll a number cube, 6 things can happen. And that gives me 12 things. This is actually called the fundamental counting principle. I don't know if it's E-L-E. I think it's E-L-E. Okay. So we're going to move into this. So we can do a tree diagram for these, or we can do a table. So I want to show you, I already showed you the tree diagram for, I'm going to call this one 2 coins. I already showed you this, heads or tails, and then heads or tails from each of these. This is called a tree diagram. So I've got heads, 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 tails, tails, heads, tails, tails. This would be my sample space, okay? The table is another way of doing it. So you kind of do this and you say, you can get heads or tails on the first toss and heads or tails on the second toss. And then we're going to fill out the table accordingly. So this would be the heads, heads. Do you see that's what goes here? And this would be tails, heads. And this would be heads, tails. And this would be tails, tails. If you do the table, then you actually already have all the outcomes listed. You already have the sample space is actually in the table. But if you just do a tree diagram, you have to then write the sample space separately. You can't just leave it in the tree diagram because I want to make sure you understand what the tree diagram is representing. Okay, I think I want to come back to this and do this on another day, but we're going to talk about things like arranging 5 books in your locker and all the different ways that you can do that. And we're going to talk about things like if there are 10 people in a race and only 3 people can win, what does that look like? How many different outcomes there are? So I'll come back to that on another day. Hope you guys have a good day. Bye.